In this video, we are going to write chemical equations involving acids and bases and identify conjugate acid-base pairs. Earlier in the course, we learned about electrolyte strength. Strong acids are strong electrolytes, so they completely dissociate in water. Weak acids are weak electrolytes, so they only partially dissociate. We also learned that acids react with bases to produce salt in water. The reactions of weak acids and weak bases are often reversible. That is why these reactions are written with a double arrow instead of a single arrow. In the reverse reaction, the original acid becomes the base, and the original base becomes the acid. Each reactant and the product it forms is called a conjugate acid-base pair. Let's look at ammonia reacting with water. Ammonia, NH3, is a weak base, so it accepts a proton from water. Water is amphoteric, meaning it can act as either an acid or a base. In this reaction, water behaves as an acid and donates an H+ ion to the ammonia. The products are NH4+ and OH-. On the product side, NH4+ is the conjugate acid because it can donate a proton in the reverse reaction to become NH3. The hydroxide ion, OH-, is the conjugate base because it can accept a proton in the reverse reaction to become water. Let's identify the acid, base, and their conjugates in another reaction. H2SO4 plus H2O produces HSO4- plus H3O+. Sulfuric acid, H2SO4, becomes HSO4-. It loses an H+ ion, so H2SO4 is the acid. Water becomes H3O+. It gains an H+ ion, so water is the base. Now look at the reverse reaction. HSO4- becomes H2SO4 by gaining an H+ ion. HSO4- is the conjugate base. H3O+ loses an H+ ion to become H2O, so H3O+ is the conjugate acid. Both products are labeled with the word conjugate because they are formed from the original acid and base. Here's a practice problem. Identify the acid, base, and their conjugates in the following reaction. HCO3- plus H2O produces H2CO3 plus OH-. The bicarbonate ion HCO3 becomes H2CO3. It gains an H+ ion, so it behaves as a base. Water becomes OH-, so it loses an H+ ion, so water is the acid. Looking at the reverse reaction, H2CO3 loses an H+ ion to become HCO3-, making H2CO3 the conjugate acid. The hydroxide ion gains an H+ ion to become water, making OH- the conjugate base. Now let's write the formulas for the conjugate acids of several substances. Remember, a conjugate acid is formed by adding one H+ ion because each substance must act as a base. For H2O, the conjugate acid is H3O+. For NH3, the conjugate acid is NH4+. For CO3₂-, the conjugate acid is HCO3-. For H2PO4-, the conjugate acid is H3PO4. Remember to add both the hydrogen atom and adjust the charge appropriately. Now let's write the conjugate bases for the same substances. If there is no conjugate base, write DNE for does not exist. A conjugate base is formed by removing one H+ ion. The conjugate base of H2O is OH minus. The conjugate base of NH3 is NH2 minus. The carbonate ion, CO3 2 minus, has no hydrogen atoms to lose, so it does not have a conjugate base. Write DNE. The conjugate base of H2PO4 is HPO4 2 minus. Now let's write equations showing substances reacting with water while acting as monoprotic acids. A monoprotic acid donates one H plus ion. Our first substance is HBr. HBr acts as the acid, and water acts as the base. HBr plus H2O produces Br minus plus H3O plus. HBr is the acid. Water is the base. Br minus is the conjugate base. H3O plus is the conjugate acid. Now let's do HSO4 minus. HSO4 minus donates a proton, so it is the acid. Water accepts the proton, so it is the base. SO4 2 minus is the conjugate base, and H3O plus is the conjugate acid. Finally, let's write a balanced acid-base neutralization reaction. When vinegar reacts with baking soda, bubbles are produced. Vinegar contains acetic acid, HC2H3O2. Baking soda is sodium hydrogen carbonate, NaHCO3. Apply the double displacement reaction pattern. Sodium ions combine with the acetate ions to form NaC2H3O2, sodium acetate. H plus ions combine with HCO3 minus ions to form carbonic acid, H2CO3. Carbonic acid is unstable and immediately decomposes into carbon dioxide gas and water. Overall, the products are sodium acetate, carbon dioxide, and water. In this reaction, acetic acid is the acid, and sodium hydrogen carbonate is the base. Notice that the acid and the base neutralize one another. The remaining solution is primarily sodium acetate dissolved in water, while carbon dioxide gas escapes as bubbles. For household cleaning, mixing vinegar and baking soda neutralizes both the acid and the base. As a result, you are mostly left with a salty water solution. Some people believe that the fizzing action from the carbon dioxide provides cleaning benefits.